So let's suppose I'm asked to express this function as a power series, and this problem looks very intimidating because all of a sudden we have x's and s's and we have an integral sign and it's just a hot mess. And I'm thinking, But right away, I saw something that made me suspicious, and that was integral from 0 to x. That reminded me of the fundamental theorem of calculus. So if you go back to fundamental theorem of calculus part 1, what it says is f prime of x, when f is written this way, the derivative is this expression with x plugged in. So straight up, I know that f prime of x is equal to x over 1 minus x cubed. Much friendlier, right? And actually, really easy. The r is x cubed and the a is going to be x. This looks exactly the way it's supposed to look, to be the sum of a geometric series. And that series is going to be the sum from 0 to infinity of here's my a, here's my r, and there's my little power. So that's going to be my f prime expression. I got a couple more steps to do here. 1, simplify. Powers of exponents tell me that this is x to the 3n plus 1 power, but I'm not quite done because this is f prime. So I need to use the reverse power rule to find f of x. I have the sum from 0 to infinity, and this couldn't be any easier. You add 1 to the power, you divide by that new power, 3x plus 2, and then there's a constant. But, better still, can you see that f of 0 is supposed to be 0? When you look up here and you plug in 0, it's going to be the integral from 0 to 0 of the function, which that's stupid, that's always 0. And so that means that you definitely want the c to be equal to 0. So there is my solution.